Lesson 7.5. We are still working with logs, obviously. We are moving into solving equations, though. So, lesson 7.4 seemed to go pretty well. At least the homework went pretty well because homework scores looked good. But now we're going to solve equations. So we're solving exponential equations and log equations. So some of these you'll see exponents. Some of them you'll see logs as we go throughout. Let's start looking at them. Example A. We're going to start on this front side with exponential equations. So we have 16 raised to the power of 3x equals 8. Thoughts? I'm going to go with technically you can figure out how to do this because we've already kind of gone through this part. So it's not something brand new in that, what was it, lesson 7.3 we maybe talked about it? Thoughts, Ethan? That would be your number one place to start. The first question to ask yourself, can I make my bases the same? So can I make 16 and 8 the same?
Yes.
Probably, yeah, okay. How can 16 and 8 have the same base? They're both in the 2 column, yes? I mean, technically 16 is also in the 4 column, but what's helpful is that they're both in the 2 column. Okay, so rewrite. 16 can be rewritten as what? 2 to the 4th. And then it's still raised to the 3x. 8 can be rewritten as 2 to the 3rd. Notice we got the bases the same, yes? Now, on that left side, 2 to the 4th power raised to the 3x. How can I rewrite that? Yeah, because a power raised to a power, we're going to multiply. So 4 times 3 is 12x. So now I have 2 to the 12x equals 2 to the 3rd. Was it 7.3 we covered this? I feel like it was 7.3 we covered this. Yeah, we were trying to find logs. What do you remember? The bases are the same. What am I going to do? Set the exponents equal to each other. 2 to the 12x equals 2 to the 3rd. We already know the 2's are the same. I just need the powers to be the same. So drop off the bases, and I have 12x equals 3. How do I solve the equation 12x equals 3? Divide. 12 times x, divide by 12. 12's cancel. What is x equivalent to? 1/4, because 3/12 reduces to 1/4. That part wasn't horrible to begin with, was it?
Nope.
Again, I feel like we were using a different scenario. We were trying to figure out what a log equaled, and so we had to do our left, right, middle earlier this week, or maybe last week at this point, I guess. But it was the same idea. Once you have that, get your bases the same and go from there. Okay, let's try a few more then. B. 27 to the 3x equals 81. Okay. What same base are we getting? They're both going to have 3's, yes? So according to my paper, 27 is what? 3 to the 3rd. So this is 3 to the 3rd raised to the 3x. And what's 81? 3 to the 4th. What do you know about 3 to the 3rd to the 3x? 3 times 3x makes it 3 to the 9x equals 3 to the 4th. What do we know now? Threes cancel off, and we have 9x equals 4. 9x equals 4, divide by 9, and x is 4 over 9. I know this could probably skip C and jump us down to the fractions, but I feel like you guys have the hang of these. 256 to the 2x equals 64. What base are we going? Fourth? Okay.
I mean, you could do 2.
No, it's not wrong. My brain just had a different number in it.
I did 4, but I just looked over it. So.
8. We do 8.
Be quiet, Jake. Jake, shut up.
No, we can't do 8.
Why?
Why am I vetoing 8?
Because it's not 256.
Because 256 is not 8 to some power.
Oh.
Now, again, he said 4. It caught me off guard. I had to stop and think for a moment. Because in my brain, I was thinking 2. Here's the deal. Will they both work out? Yeah. It doesn't matter whether you go 4 or whether you go 2. Because in terms of 4, 256 and 64 are both in that list. In terms of 2, 256 and 64 are both in that list. It doesn't matter which way you go. We'll meet in the end. I forgot there were 2 options to go. That's what threw me off on this one. So, if we go with 4, which is fine, 256 is 4 to the 4th raised to 2x, and 64 is 4 to the 3rd. So what do you know about 4 to the 4th raised to the 2x? 4 to the 8x equals 4 to the 3rd. Since my 4's are the same, 8x equals 3. Divide by 8. X is 3 over 8. Did anyone go the 2 path? I'm thinking if someone went the 2 path, did you maybe get 6/16? And then you had to reduce? That's my guess as to what happened there. Again, same answer in the end. Okay, let's try D then. I'm glad we did C after all. Got to talk about the fact that we had 2 directions. Yeah. Okay, so we have 1/4 equals 8 to the 3x. The numbers to focus on are the 4 and 8. And 4 and 8 can be made the same by using a base 2, yes? Now, for the beginning, if I say 1 over 4, that's going to be 1 over 2 to the 2nd, yes? Long term, am I going to be able to leave that as a fraction, though? No. How do I take an exponent out of the denominator of a fraction? Make it negative, right? We've done this before. So 1 over 2 squared is also the same as saying 2 to the negative 2. Okay? So you're still looking for that same base. The difference is when you take it out of the denominator, it's a negative exponent. Okay? Backtracking for a moment. What do we know about 8? It's 2 to the 3rd raised to the 3x. 2 to the 3rd raised to the 3x becomes 2 to the 9x. Are we okay with what I've done there? Because from here on out, you know what to do, right? My 2's are the same. Drop the 2's. And then have negative 2 equals 9x. How do I solve for x? Divide by 9. What are you going to give me as an answer here? Negative 2 over 9. go a decimal direction with these and give me a decimal answer. But on a situation like this, Math Excel is probably going to say, we want a fraction. And so that's why, notice I haven't picked up my calculator yet today.
So on a test, you wouldn't care about it.
No, yeah, on a test, if you wrote like -2/9 is going to be -0.2 repeating. If you wrote that down, that's equivalent. I'm not going to count that wrong. Math Excel might count it wrong, but that's just because they're more picky about their forms. Okay, what about E? What is the number you see? A 5? Did someone say 25?
I mean, I do see it.
That's the correct math, isn't it? 625 is 25 squared, right? My brain is all of a sudden second guessing me. So, not on the paper, but we could do it. I was going to stick with the paper. But, okay, so, hadn't thought about it. 625, if you happen to know it, is 25 squared. Because the square root of 625 is 25. You could go with a base of 25. Does my base have to be on this paper? No, this is just your helper tool. It's the whole concept here that matters. So if you want to go 25, go for it. You'll meet me in the end. Now, for the rest of us, I'm going to stick with the paper just because that's what's, if you look back, that's what's going to help you understand it better. What's on the paper that can help me here? The 5. So 1 over 25. 25 is 5 squared, right? So 1 over 5 squared raised to 2x, and 625 is 5 to the 4th. What do I do with that 1 over 5 squared? Yeah, we're going to change it to a negative. So it becomes 5 to the negative 2. But then raised to the 2x makes this 5 to the negative 4x. Still equals 5 to the 4th. And what'd you come up with? Negative 1. The 5's drop off. Negative 4x equals 4. Divide by negative 4, and x is negative 1. Okay? Got the basics on that section. Okay, next section. Notice we are still solving exponential equations, right? Are they really that different from what we just solved? No, in that they're still exponential equations. A was 16 to the 3x equals 8 above. Now we're doing 15 to the 3x equals 285. Change the numbers. What's important here, though? Yeah. 15 and 285. Are you finding these numbers on here? No. 15, the only way you can get 15 is 3 times 5. So can I rewrite that with powers? No. 285? It's not a perfect of anything. Perfect square, perfect cube. It's not a perfect of anything. So we have to have a plan B here. Okay? Plan A should always be, can I make my bases the same? And if I can, let's use the method we just talked about. Plan B is, what do we do if we can't make the bases the same? Okay, what's our big topic in this chapter besides exponents? It's exponents and logarithms. So here comes the logarithm aspect today. Because I can't make the bases the same, we are going to take the log of both sides of the equation. Because remember, as long as whatever you do to one side, you can do to the other side, right? So we're going to take the log of both sides. Meaning, my first thing I'm going to write is this is the log of 15 to the 3x equals the log of 285. So when I ask you to take the log of both sides, it's really just writing the word log in front of them. Okay, ultimate goal, solve for x. When I get down to the end, I want this to say x equals. My hint is to think about lesson 7.4 that we just did and the properties we've learned. There's a property that will help me right now. Any guesses? Yeah, what's the power property going to allow me to do? Take this 3x and move it out front. Okay, in other words, the good news is I want that 3x out of my power. So now when I write this out front, this is 3x times the log of 15 still equals the log of 285. Okay, so take the log of both sides. Use the power property to pull that power out front. You see where we're going? Again, my job is to solve for x to get x by itself. Wait. We are going to use the calculator, yep. How do I use that calculator? What's the step we're going to do here? Not subtract it over. Divide it over. So because it is 3x times log of 15, the opposite of timesing is to divide it. Now, what's the other piece that's also hanging out there? Besides, we want it to be just x equals. What's also hanging out besides the x? The 3. So keep in mind, this is 3 times x times log of 15. All three things are being multiplied. So we're going to divide. You can do this two different ways. You could go ahead and do log of 285 divided by log of 15. You can get that answer. And then how are we going to solve for x if I have 3x left? Divided by 3. And that's fine because we're using a calculator, right? So that's not ugly math because we're just punching buttons on the calculator. The other option is, if you want to, you could do this all division at one time. Okay? There's tricky things both ways, but ultimately it's all about dividing. So since it's 3 times x times log of 15, I want to divide the log of 15 over. I also want to divide the 3 over. And you can do this all at once. So we're dividing by 3 log of 15. Do we see how this is working? My 3's cancel. My log of 15's cancel. So I end up with x is going to be whatever log of 285 divided by 3 log of 15 is. Now, if you go this direction, beware with the calculator. It's probably going to be best if you put parentheses, at least around that denominator. Because 3 and log of 15 are two different things. Now, honestly, the easier thing might be to do log of 285, divide by log of 15, and then divide it by 3. That will get you there. Or it's log of 285 divided by 3 times log of 15, put parentheses around it. This is where it's incredibly important that you play with the calculator that you like to use and make sure you can get a correct answer. Does that make sense? Don't wait until the day of the test. I'm not sure how to use this calculator because I'm going to be a little frustrated with you. It's not that it won't help you, but practice is going to make it better. So if I do log of 285 and in those parentheses, And then our option, divide. Since I have more than one thing in the denominator, I can start a set of parentheses, say 3 log of 15, and then I'm ending 2 sets of parentheses. There's the magic number you're looking for to come up on your calculator. Okay, that's your final answer. Did you have success? Because if you didn't have success, try it again, see what you can do. Let's see. I have 4 decimal places written down. It says round to the nearest thousandth in the directions, which is 3 decimal places. But I have 4 written down, which makes me think in homework you have to do some 4 decimal places.
I think so. Yesterday had 3.
It had 3 yesterday, but there might be 4 today. I'm not sure. So if I go with 4 here, 0.6957, but 6 tells the 7 to go up to an 8. Okay. If you didn't like those parentheses, or if your calculator is a little more difficult to use, honestly, the best thing would be log of 285. You could do divided by log of 15. You can hit equals there, and then you can do divide by 3. And you can reverse those steps as well. Okay? Depends on your preference, depends on your calculator. Do we get it figured out? So yeah, I said you had to have your papers out today. Those would be helpful, but I also said calculators. Depends on the problem. Technically, could we do the problems above using this method with the calculators that we just came up with? We could. To me, I don't know, the calculators almost make this a little bit more difficult. I mean, take the log of both sides, but it's doable. Okay, let's try B to practice, and then we will probably jump down to the bottom row. So 5 to the 2x equals 130. First question to ask yourself. Can they be rewritten in the same base? 5 is 5. It's not going anywhere. Can 130 be rewritten as 5 to some power? No. So, what's my job then? Okay, so take the log of both sides first, right? It can't be made the same. Take the log of both sides. So I'm going to write the log of 5 to the 2x equals the log of 130. And I get it. Some of you guys are going to mix steps in together and everything here. But next official step is that power property he wanted to do a moment ago. So bring that 2x out front. 2x times log of 5 equals log of 130. How do I solve for x and get x by itself? Yeah, divide everybody away from x. So since this is 2 times x times log 5, we have to divide the 2 away, and we have to divide the log 5 away. So we're going to be dividing by 2 and log 5. Again, remember use parentheses around that denominator. So 2's cancel, log 5's cancel. X is whatever your calculator tells you at this point. Did you guys get it? What'd you get? That's what I have. So, for me, I'm going to do log of 130 in parentheses divided by, begin parentheses, 2 log 5 end in parentheses. Okay, there's your calculator screen answer. We're going to 4 decimal places. I do agree with 1.512. Right now it's 1, but the 8 tells it to go up to a 2. Okay, do we have the basics? Are you guys okay if I skip C?
Sure.
If you are curious and you've worked ahead and it's going to kill you if I don't tell you, I have written down it's 2.0918. If you have the need to know that answer. If not, don't worry about it. I know some people work ahead of me and they don't like to have links in their notes or whatever, so. Okay, let's look at D. Going to change things up a little bit on D. What's different? Yeah, inside my power is a little bit different. Yes? But overall idea is still the same in that there are 2 bases. It's 5.2 to some power equals 400. So your first question still is the same. Am I getting those bases the same? Not with the 5.2, right? No way with the decimal. So since those bases aren't becoming the same, I'm going to take the log of both sides. So the log of 5.2 to the 3x plus 1 equals the log of 400. Okay, so step 1 is still the same. Step 2. What are we going to do? Okay. It's still using the power property and moving the power property out front. Okay, that's not changing. So when we move that power out front, the power moving out front is 3x plus 1. So I now have 3x plus 1 times the log of 5.2, and it still equals the log of 400. Did you catch what I did with 3x plus 1? I put in parentheses. And yeah, those parentheses are kind of necessary because that 3x plus 1 is 2 different terms. It's not just one term like it's been in the past. So there's a couple different ways we can do this. But my job is still to solve for x. Thoughts or guesses about options? There's right ways to do this and there's wrong ways to do this. There's multiple right ways. Probably multiple wrong ways too, but. Divide by what? Okay, I'll agree with we could divide by log of 5.2. Okay? That is an option. Because it's 3x plus 1 times log of 5.2, we could divide the log of 5.2 over. Okay? I can agree with that. The other option right now, if you wanted to,
Would you divide log of 400 by log of 5.2 and then treat it like normal equation, subtract 1 over and divide by 3?
Yeah. Okay. And that's probably the easiest option for me to take, you guys, is that this log of 400 divided by log of 5.2, it's going to be some messy decimal. Honestly, I'm just going to leave it written as that fraction until I get to the end. Because what I'm going to do is I'm not going to pick my calculator up until I get to the very end of this problem. And then I'll plug it all into the calculator at once. Okay. The other option, if you wanted to, if someone ever suggested it to you, log of 5.2 is like a number. We could distribute this into the parentheses. I don't think it's the easier route. I'm not saying that by any means. But that's another option, that you could do log of 5.2 times 3x, log of 5.2 times 1, and then solve it like a normal equation. My preference, though, or what tends to go over better is, let's divide that log of 5.2 over. So, since it's 3x plus 1 times something, we're going to divide. So, what I'm going to write on my paper right now is I still have 3x plus 1, yes? On my right side, I'm just going to write down log of 400 divided by log of 5.2. A, I don't want to have to keep writing a messy decimal. And B, if you round that messy decimal too much, it could throw off your final answer. Okay? So, as Jay said, typical equation. If it's 3x plus 1, we're going to subtract 1. So that means we're going to subtract 1 over here. I now have 3x equals log of 400 divided by log of 5.2, all minus 1. And then what do I still have to do? If it's 3 times x, we're going to divide by 3. So I'm going to divide whatever my calculator tells me the answer is by 3. Okay. Practice with the calculator, guys. Don't wait till test time to figure out how to work the calculator. I'm going to start with my logs. I'm going to divide my logs. I'm going to hit equals after I do that. I'm going to subtract 1. I'm going to hit equals after I do that. And I'm going to divide by 3. That's my recommendation of how to do this. You got a different way and it works out the same in the end? Go for it. Log 400 divided by log 5.2. I have that typed in. I'm going to hit equals because that kind of tells my calculator, like, okay, take that calculation. Then I'm going to minus 1. I just type minus 1. I can hit equals. That's where I'm at now. And now we're going to divide by 3, hit equals. Did you meet me in the end? That's good news. Okay. 4 decimal places. 10 thousandths, 0.878. Currently a 0. The 4 tells it to stay as a 0. Okay. Those are kind of the challenging ones. When we have more than just a basic x term in that exponent. Let's go ahead and try E. Get the idea down here. Okay, you got it? Step 1 is what? Take the log of both sides because our 5 and 9 going to become the same in writing them in powers. Not happening. So, log of 5 to the x minus 3 equals log of 9. What do I do here? Power property says I can take that power and pull it out front. Remember to put it in parentheses when you do that. X minus 3 times log of 5 equals log of 9. Do you know the next step? Divide by the log of 5. So I now have x minus 3 equals whatever log of 9 divided by log of 5 is. And you could go ahead and get that on your calculator. You could write that decimal down. I just would not clear it out of your calculator. I would leave it on your calculator. And what's my finishing step? If it's minus 3, you're going to add 3. So, Make sure you can punch in on your calculator. Log of 9, divide by log of 5, adding 3. Some of you guys have the answer. What'd you get? Okay, yep. So log of 9 divided by log of 5. Easiest to hit equals there. And then in this case, I'm just adding 3. So 4.3652, and the 1 tells the 2 to stay. I'm going to ask while our brains are on it. I don't know that we can really work through this whole problem. We might be able to, but probably run out of time. Okay, this one's slightly different again, yes? How is this one different? Yeah, there's this 2 out front here, which means you don't want to make your first thing to take the log of each side. Okay, I don't want to take the log of each side till I have some nice neat number raised to a power. So do you have guesses of what we can do if I'm not just going to start by taking the log of each side? Not multiply it. Not divide. Yeah, how can I move this 2 to join the other 2?
Oh, I think you're just.
Okay, yeah, you're on the, I see what you're doing. Okay, so I guess what I'm trying to say is, how do you get that power to the x plus 1 is the only thing on one side. And your best bet there is to move the 2 over. I would maybe multiply or divide by a negative so I have positives to work with, because we don't want to take the log of negatives. And then, same old steps, right? Okay, so I will start with F tomorrow. We will need to talk a little bit. We'll do a word problem tomorrow, and we'll do some of the log equations tomorrow and talk about those. So homework should be available. You can get started on it. Okay. We will complete information so you can finish it tomorrow then.